Hello, everyone. Welcome to today's session, Building Generative AI Applications on AWS featuring deepset. Today, I have two thought leaders join me, who is Joanna and Dimitri. Myself, I'm Mia Chan. I work as machine learning specialist solutions architect at AWS. I help customers onboard their machine learning journey on AWS. So, before I start the session, how many of you are interested in generative AI? Yes, I love it. Okay. How many of you already started building applications around generative AI? Yeah, that's really good. And how many of you already start leveraging the model or Haystack from deepset? Cool. Cool. Okay, so hopefully after this session, you will have more understanding about what's our offering for generative AI on AWS and the story from deepset. Today's agenda that I will go through what is the generative AI on AWS. The second part and the third part that Joanna and Dimitri will tell the story. So first, let's start to talk about why generative AI comes along with a lot of attention, like the session today, right? So first, you will see some data points and a graph that I put it here. Stable Diffusion accumulated the 40K stars on GitHub in first 90 days. If you check the GitHub today, it's already 53K. So you see, like the attraction and all the things that come along with generative AI, text to image, text summarization, or question answering on documentation. These are all the things that in the scope. And ChatGPT, of course, that everyone starts to talk about it. It comes along, reach 1 million users with just 5 days. So today we understand about how quick the generative AI brings everyone's attention. And we also want to talk about more about the use cases of generative AI. So you probably already know some generative AI application use cases. For example, like on Amazon.com, that the search result that is generated from generative model. And also, every day, hundreds of the users or millions of the users that is using Alexa every day. Your experience, the conversational experience that come along generative AI model. So if we start to think about what is the model behind it, we were starting from foundational models. Foundational models, it's come along by the tons of the training data with hundreds billion of parameters. When we talk about the generative model, that we will also talk about numbers of the parameters. It's a way that we measure how complex the model is, what's the sophistication levels of the task it can perform. So that's how we start the story to talk about the billions or trillions, like the parameters of the machine learning model. And then when it comes to the use case of it, we start to talk about the model itself help us to generate content. The content could include text, images, audio, and video. These are the use cases that we see often that's been used by generative AI model. Next, you probably would like to think about, hey, how can I use generative AI model in my business? Then it comes to fine-tuning. When we look at the fine-tuning, we are thinking about prompt engineering. I hope you heard this often enough these days. And also you can do small amount of the fine-tuning. Bring along the document that is focused on in your industry. Also let the models learn some terminologies that you use often. Do the minimum fine-tuning to make the model to understand more about your use case. Next, when it comes to generative AI model, since it's a complex model that it actually can take overs, like before the days, like the single models can achieve that. So before you might need 3 to 5 models to achieve a task, and now you only need one generative AI model to achieve that. Now, I also want to share how we see in the whole generative AI ecosystem. I shared like 3 types of the customers that we see on the field. The first type is about producers. Producers are like Stability AI, like AI21, and they are providing the foundation models to the market. And those foundation models can be used by solution vendors. So solutions vendors take that foundation model, build application around it, just like several of you just raised your hand, right? You can use it to build application around foundational models, and then your users, customer, that they could be individual users or enterprise users that could run it with the generative AI applications. So since we are at the startup stage, you could see SUP startup is in each of the categories. So probably you already start brainstorming about it. How can I leverage it and run it for my business to accelerate my customer's journey? With that, I want to share 3 layers of the AWS offering that we come along with generative AI as a service with Code Whisperer and Amazon Bedrock. We also have our good friend, Amazon SageMaker, come along with JumpStart, Foundational Model Hub. And you can also work with SageMaker on open source model hubs like models on Hugging Face, and you can have more options there. And the third layer, hope people in the behind can see it clearly, the machine learning frameworks. Some people also leverage our EC2, ECS, and EKS system to train and build inference your model on it. So these 4 options are all available on our platform. If I want to dive deeper on Code Whisperer as an example, so some of you might already try it out, like Amazon Code Whisperer. You can use it as your good friend when you're doing programming. So it can generate a code that from your English comments. It can finish the function for you when it's needed. Another one, Amazon Bedrock. It's the service that we just announced in the mid of April. I assume many of you just heard of it, right? And for this service, we provide 2 types of the models that I categorize it. First is foundational models from Amazon. You will see Titan Text and Titan Embedded. These are like the large language models that from Amazon from us. You can leverage it to play it with managed embedded, to do it like a distance calculation between the tasks, distance calculation between the documents, find out what's the most relevant document for your question, things like that. And we also include foundational models from the model providers like AI21 Labs, and also with the several models that we list here. So what does that offer comes about? As I mentioned, generative AI as a service. That means you can use it with an API call to load the model, to host it, and then potentially can fine-tune a bit, depends on your use case. Now, I know a lot of our startup friends are hands-on group, so you probably will be more interested in this one for running foundational models on Amazon SageMaker, JumpStart. So on the JumpStart, now if you log in with AWS Console, you already see a list of the models that are available that you can use. And you can just choose them and host with the instances that are available in your region and try out the different generative AI use cases like text summarization, question and answering, and also text to image generation, things like that. So JumpStart is a really quick starter that you can leverage in SageMaker Studio with a one-click deploy, or you can play around with the notebooks. And there are also some models that is in the Get preview. So it's on demand. So you can put yourself in the waiting queue and wait for our sharing for your access to some of the models. I would say I personally really love the third option as well, that not only the JumpStart offers several models, but also the leverage of the Hugging Face model that can help you to have more choices. For example, if you already visit the Hugging Face website that you probably know, once you select the model, it can also generate you a sample code if you want to host the model with specific generative AI task. So then it comes along with this script. You can just copy paste, and then you can start running an experiment. So I want to take one step back to think about what if you already start to load the foundational models, either with JumpStart or with open source model hub. You might start to think about fine-tuning. So when we talk about fine-tuning, we are talking about specific use case, because we are not going to retrain all the big model. We are going to fine-tune those parameters that is relevant to your use case. For example, if you are doing text summarization, that you probably want to fine-tune with the text and the content that is relevant for your industry and use case. With that you provide some data, and to do the fine-tuning, it could be run on Amazon SageMaker. So from this part, I was just showing the overview about how the code snippets will look like. First, you usually will start to load the data set, and later on start to use tokenization to make it from unstructured data to the vectors that can be understood by computer. Next, you might want to load the models from pre-trained model, and then you select which model you want to load. Next, you specify what kind of the training job you want to run. How many epochs, what's the batch size, and what are the types of the machine that you want to run it. This is the place to set up the configuration and the parameters for your training job. After you start a training job, then you will save the model, and you also can do the evaluation. So the whole life cycles to develop a large language model that you can be done on SageMaker or with the next option. The next option is also come along with open source model with EC2, ECS, and EKS ecosystem. So I know, for example, deepset is the case that running their AI machine learning workload on Kubernetes. So when you run your training job and inferences job on Kubernetes, there are several things that you can leverage. Like when we provide orchestration with services, we also provide the core infrastructure for compute. And for these several compute instances, some of them are really dedicated for AI and machine learning tasks. So this one that I would like to share, especially TRN1N, it's instances that optimize with AWS Trainium. It's best way that you can do the training job. And it's also 50% outperformance than the other just general usage for EC2 instances. The last one I want to introduce about is the Inference Tool. It's the one that when you finish the training, you are thinking about to host the model. It comes along with the accelerator inference in it, and you can have 40% of the outperformance than the other model inferences type. So from here, I would like to switch to the next part and invite our delightful Tuana.
Thank you very much. How do I switch over to the next? Okay, I think I've got it. Can everyone hear me? Great. Okay, so I'm not used to this setup. Hello, everyone. My name is Tuana, and I'm one of the developer advocates at deepset, mainly for Haystack. So I'm just going to dive in. I hope there are some Python engineers here, because there is going to be a bit of code at the end. And if you can't see the screen, don't worry about it, because I'm going to be walking you through. It might be a bit too small, the font, but let's dive in. All right, so I'm going to be talking about how you can build generative AI applications that work with your data, and specifically how we can do that with Haystack. So a bit about Haystack before that. So Haystack is our fully open source Python NLP framework. And it's built on this idea of pipelines. To build an NLP application, generally, there's a lot of components that are needed. You have to think about how you prepare your data, where you store your data, and what kind of NLP application you want to actually achieve at the end of the day. And one of the most common NLP applications, you can look at the far right side of this screen and you'll see two components, a retriever followed by a reader. And a reader is an extractive model. But the idea with Haystack is you are free to mix and match these various components based on what kind of NLP application you do want to get to at the end of the day. And it provides you a choice of which model providers you want to use, whether that is open source via Hugging Face, or whether it's OpenAI, Cohere, Azure, along with, of course, the choice of what kind of database you want to use. That might be a vector-optimized database, it might be Elasticsearch, OpenSearch, and so on. And if you scan this QR code, you'll be able to see our GitHub repository for Haystack as well. All right, so we talked about the right-hand side of this pipeline and a retriever followed by a reader. So I want to quickly discuss the reader. A reader is a component that is basically a wrapper around an extractive model. And this is important because extractive models are still what most search applications are today still powered by. And these models are tasked to extract answers to a query from a given context. And this is important because it's where it really differs from how generative models work. So on the left-hand side, you'll notice that we have query and context as inputs. But we want to be able to do the same thing and get accurate answers with a generative model, because this way we're going to be able to get human-like answers that are based on facts. So this is where we talk about a generator component. You'll notice that on the left-hand side, we've taken away the context, because a generator component does not need context. These models, generative models, are tasked to generate human-like answers. They are not necessarily tasked to extract answers from a given piece of context. That is up to us to provide that context to them or not. So in this talk, I'm really going to be talking about a strategy we called retrieval augmentation and how you can achieve retrieval-augmented generative applications with Haystack. So in the next slide, I have an example of what you might be able to achieve with a generative model. And I used an interface that I'm pretty sure most of you have already seen. This is a query that I sent to ChatGPT. And I said, write me a poem about this session's name at AWS Summit 2023. This is a good example because it's not actually a question. We're asking it to generate us some brand new content that did not exist in the world before. And what did I get as a result? This beautiful piece of literature. A session on generative AI was key, featuring deepset's expertise, building applications with ease. It's lovely. Now, what if I ask it a question? I say, tell me about one of the speakers. And what I got as a result here is interesting. One of the speakers at the Building Generative AI Applications on AWS featuring deepset session at AWS Berlin was Dr. Joanna Doe. And it gets a bit more worrying afterwards because it says she is a renowned AI researcher and the co-founder of deepset. And I don't know Joanna Doe. If we do have such a co-founder, I've never met her. But the problem here is that this sounds very plausible. So we're going to look at two components we have in Haystack that allows you to mitigate this happening, and for us to be able to generate human-like answers, but based on our own data. Those two components are the prompt template and the prompt node. The prompt template is basically a way we can flexibly modify our prompts and basically provide a blueprint of how we want to interact with any given large language model, whether that be from OpenAI or whether we pick a model from Hugging Face and so on. And the prompt node is really our interface. It is the thing that is sending the queries and receiving answers from these large language models. And you can decide to use OpenAI or anything else as well. And in this particular case, in the next slide, I'm going to have a short code snippet of just me using a prompt node and sending a query to an OpenAI model. Here you see I've defined a prompt node, and I said that the model is text DaVinci 003, so GPT-3. Obviously, I need to provide my API key. And I say, when will Miloš travel? By the way, Miloš is one of our co-founders, not Joanna Doe, and I get a response. So I'm using OpenAI with the default setup, so I'm just sending this query to GPT-3. And it says, Milos will travel when it is safe to do so. Okay, very plausible again. But I want to remind you of the pipeline setup that we had a look at. I'm not going to dive into the details of the retriever component, but basically what we want to achieve is replace that reader that we saw at the last bit of a pipeline with a generator, but before that, we want a retriever. This retriever interacts with our own database and is able to, given a query, say, this is the most relevant document in your database. And we're going to see how we can use a trick to embed the contents of that document or data we retrieved, most relevant to our query, in our prompt to any large language model. And that way, the prompt not only has the question you asked, but the most relevant piece of context that it can use to generate an accurate answer. So let's imagine we have an open search database. And I actually know when Milos did travel, by the way. This is an old ticket belonging to him. From the 14th of November, I believe it's from Stockholm, Stockholm to Frankfurt. So let's assume we have this, we are storing this in an open search database. So the first option was what we saw before. The first option is we just query, with the prompt node, we just query GPT-3. Now, I think I'm blocking a lot of it, so don't worry if you can't see this. But the second code snippet is we are using the prompt node, and we're saying use a prompt template called question answering. This is one of the default prompt templates we provide in Haystack. And the trick here is the prompt template now is expecting us to fill it in with something. The next component that I am declaring is the embedding retriever. This is a retriever that's simply given a query, goes through the documents that we have, and says, this is the document that matches your query best. And the next thing I'm doing, I'm defining a pipeline, and the first node I add is the retriever node. So this is the first thing that is getting the query at all. And then the second node I am adding now is my answer generator, the prompt node I declared. Now when I say, when will Milos travel? I'm not sure if people on the right-hand side can see this, but I say it says Milos will travel on 14th of November. This is a lot more accurate. The point here was that the first result we got, Milos will travel when it's safe, sounds plausible. It's human language. However, in this way, with the retrieval augmented strategy, we can ensure that the large language model is getting the document that we wanted to generate the answer from. All right, so we talked about the prompt node. We saw that we were using a prompt template that we have by default called question answering in Haystack. The last example I want to give is what happens if I want to create my own prompt template. This is a lot of text again, so people at the back, please don't worry about not being able to see it. But this is an example of how you might create your own template. Here I've defined a prompt template where I've called it Twitter voice. And I'm going to share a QR code that you can screenshot and then maybe try out the demo yourself after this as well. Here, I've defined how I want to interact with the large language model I decide to use with the prompt node to begin with. And in this example, I say, you will be given a Twitter stream belonging to a specific profile. Answer with a summary of what they've lately been tweeting about, in what languages, etc. And I also ask it to give an example of the overall tone of the Twitter user. Is it positive, political, sarcastic? I've gone even further. I've given examples of what a Twitter stream might look like and how you would then, in that case, respond. But the most important thing to notice here is way at the bottom. I have something in my prompt that says Twitter stream with something in curly brackets. Those curly brackets, I say tweets. This means now I can interact with my prompt node at query time by providing it something in the tweets argument. So I can inject essentially the Twitter stream based on the username at all. If you do want to try this, you can scan that QR code. And this is something I tried on my own username, and it's a great example of retrieval augmentation. If I search my username, Tuana Celik, I get this user has been tweeting about a wide range of topics, including LLMs, Haystack, NLP, open source, and social issues, mostly in English, but also in Turkish. This is very accurate for me. And the reason I was able to do that, in my query to the OpenAI model that I decided to use in this demo, I am embedding at query time the Twitter stream that belongs to me. So this should hopefully give you an idea of how we can build generative AI applications with a retrieval augmented approach using Haystack. And now I am going to hand it over to my colleague, Dimitri, who will be talking about how to do this at scale. Thanks.
Hey, so my name is Dimitri. I'm engineering lead at deepset, and I'm going to tell you a little bit about NLP inference at platform scale using Kubernetes. NLP is what we used to call large language models before GPT. So yeah, whenever I say NLP or LLM, I mean essentially the same things here. Platform scale here means that we have millions of files uploaded to our system, and roughly like thousands, maybe tens of thousands of pipelines. The use cases that we're going to be talking about are the use cases that Tuana just demonstrated, and I'm going to be talking about how to host them. So, off to the first slide. So the first use case is us uploading the data to the system. So before the system knows about Milos flying to Copenhagen, we need to tell the system that he is. So for that, we would need to upload all our knowledge base file by file to the vector storage. So if we are talking about millions of files, it means that probably you're not going to be waiting for each particular file to end up there. You're rather going to be uploading thousands of them and then going to expect them to appear in the system within 1 hour or so. That means that we are very sensitive to our throughput here and not that much to the response time of the system. That makes this use case perfect for batching. First, a little bit about how it's structured. So on the left side, we have our files. Then we transform them into paragraphs. Then this crystal ball depicts a large language model that generates for each file, generates a vector, semantic vector embedding that goes into the vector storage. So in order to build this system, you're going to need a few components. Some of them are from AWS, some of them are from Kubernetes. So if you are uploading files to Kubernetes or to AWS, most probably they're going to end up in S3. Later for batching, you can use different streaming systems. One of them is SQS, where you can make it so, configure it so very easily that each file that ends up in your S3 is going to send a message to SQS queue. Then you can create a small batch processing job. It can be a job or it can be a deployment that's going to pull the data from SQS, bundle the files into batches, and then send that over to your vector storage. So here I would suggest you to use a COP operator to provision each of these pipelines, because it's fairly simple if it's just one pipeline. But if you are speaking about thousands of pipelines, you need some operator to manage all of that as one big thing. And COP allows you to bundle together AWS resources and Kubernetes pods, deployments, and other artifacts as one deployable unit. So OpenSearch is one of the possibilities here. You can really go and scale up to millions of documents with OpenSearch. There are also other options for vector storage, like VV8, Quadrant, Pinecone, and others. OpenSearch is kind of off-the-shelf, easy solution. So if you are starting, I would encourage you to consider it. One more thing that didn't end up on this slide is Keda. Keda is a scaling framework. It can scale your batch jobs fairly easily based on the amount of messages on your queues. So it can work with SQS queues, it can work with Kinesis, it can work with pretty much anything. So Kubernetes can't do that on its own, so Keda is very helpful here. I think it didn't make it to the final slides, but we also published a couple of days ago an article about how to organize that. I would encourage you to check our social media for that. Then the next use case is the second part of the journey. Once we have all of the documents that we are uploaded in our vector space, we also have a user that's gonna ask questions. So here, once again, crystal balls depict large language models. You have a user, they ask question, the question gets converted into a vector. We search for the closest documents closest to this vector, and give them as a context to our large language models together with a question. It gets back to the user. So you can see how user waits for the response to their question in this loop, which means that latency is very important to us here. And we have large language models, which also means that we're going to have to use GPUs because they are very compute intensive. Oh, I see, it's not the last version of the slides. Anyways, so to configure, in order to enable your Kubernetes to work with GPU as a resource, the same sort of resource as CPU or memory, you can use Nvidia device plugin that will make GPUs first-class citizen of your GPU, of your Kubernetes. And if you have Kubernetes node that carries GPU, you can easily say that, okay, I want this pod to get 10% of it, that pod 20%, and so on. Because we are using GPUs, it's quite expensive compute, and you don't want to waste this resource stale. So NVIDIA device plugin will help you here. The last thing here is auto-scaling once again, because whenever you have a lot of users asking questions, the load goes up fairly quickly. But once again, Kubernetes doesn't know about your GPU metrics. It doesn't know about GPU utilization. So you need a way to tell it somehow. What you can use is the CGM exporter. It will expose GPU-specific metrics on your nodes. And if you have GPU metrics on your nodes, you can connect them with your Prometheus, you can connect them to your Grafana, you can monitor it, but more importantly, you can configure your horizontal pod autoscaler to respect these metrics and do autoscaling based on it. Yeah, so that's it from my side. Off to you, Mia.
Thanks both to Ade and Dimitri. So now is the time that we actually have some minutes left. And I see Daniel already raised the microphone there. So later we will open a few minutes for Q&A. Before we move into the Q&A, I would like to just share your exhausted list. So you can't have it, either take a pictures and then zoom out offline, or later on, hopefully we will share the slide deck afterwards, right? So then you guys can get all the ideas and resources on it. Okay, 3, 2, 1. too much pictures for today, right? So today that first you probably will see like we have several booths out there. After this session, then we can slowly move to the startup loop just right next to it. So later on in the Q&A part, you can ask the questions when we are here, and after the session, we will slowly move to the startup loop. That is where you can find us. And after you got home, probably like today, you are so exciting to learn the things that you heard today, like all the open source model, like Kubernetes that Dimitri mentioned about, and different models that skillsbuilders.aws is one of the websites you definitely want to visit. My personal preference will definitely check the several samples that released from us, and I will also definitely check the deepset space on Hugging Face website. So probably some of you already using the model from deepset, but probably you haven't noticed. I will take example like JumpStart. If you are running the document extraction with German text, JumpStart model that is also from deepset as well. Some of my customers already leverage with JumpStart large or small models on it. So I would definitely suggest you to check it out. All the models, services, they are shared from the deepset. The last one, I would like to give a big plus to our co-presenter, Tuana and Dimitri. And a small plus for myself. Yeah, right. And use the time, have the phone, they take the survey. The code is STP306. Leave questions, feedbacks, everything out there. Just let us know. How do you feel about the session? What do you want to hear more? And so on.